We are talking about the structural engineering projects. Okay, so as a structural engineer, we get the projects. Let's say we are getting a project of RCC building design. Okay, so first of all, I will tell you what is the process of work, and then we will go in detail regarding the design basis reports. What is this? So see, whenever we get project of RCC building in the structural consultant office, okay, structural engineer office. How the project is done, let me tell you the flow of the work. Let's say there is a client of any project, and client, let's say he is a builder, for example. So he want to construct a building and he want to sell the flats. So there will be architects appointed in the project. Okay. Then there will be geotechnical engineers appointed in the project. Geotech engineers, right? And there will be contractors. And there are many other consultants also, other consultants. And then he will also appoint structural consultant or structural engineer. So these are the people actually who are working on the project. So now we are discussing regarding the structural engineering, and the design basis report is also regarding to that topic. Okay. So structural engineer gets architectural drawings in the office, without which he cannot work. So architectural drawings he gets. Then he gets a geotechnical report. He gets project information. And second thing is that structural engineering is having IS code references. So he requires IS codes. And then he requires analysis knowledge and design knowledge. Okay, analysis and design knowledge. So these are the things which are required in the structural engineering actually. So this part, architectural drawing, geotech report, project information, these are the inputs which are required for the project. And this is something we can say output or working output, let's say. Working and output. So generally this is the scenario in any structural engineering projects, either it is a building or other projects like industrial projects or water tanks or like. This analysis and design, nowadays we generally use the softwares for this. Okay, so we do the software analysis using, let's say, STAD or ETABS, or we can do the design using softwares. So the softwares may be RCDC for buildings. STAD also can give you the design, or ETABS also. Okay, and there are many methods like Excel programming and all. So this way we can do the design also, and manual calculations are also possible. The softwares are now essential because we cannot do the calculations very fast manually. So softwares are very much. And then third stage is drawing preparation. Okay, structural drawings, I would say. The structural drawings are prepared. Am I audible? I just want to confirm again. Am I audible?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay, thank you. And then structural drawings, and these structural drawings goes for site construction. Okay. The contractor will use this for. So this is the overall flow of the work. And this is the structural engineer scope. This is the area in which the structural engineer is working. Okay, so there are many other people, but their role is different. Architect is doing architectural drawing, geotechnical engineer is doing geotechnical reports, contractors are doing construction, and other consultants doing their job. And structural engineer requires all this information. So the first part of the structural engineer is whatever information he gets from all the people, architects, geotechnical engineers, or clients. This project information we get from the clients, and IS codes, whatever he has learned. Okay, So every information he needs to compile together first. So because if he want to do the analysis in the software, without this information, he cannot do anything. Without inputs, he cannot do the analysis in the software. And without inputs, he cannot do the design in the software. And without input, he cannot prepare the drawings. So that input is very much important. And that input, we generally call it as a design basis report. What is the basis or what are the inputs we are using for the structural calculations and analysis? So this is design basis report, shortcut is DBR, okay? And this is nothing but inputs required for the project. Inputs required. So let's see, and this design basis report is required as a documentation work in any project. It is referred, it is a, we can say, authentic document. Generally, this document can be used in government projects, okay, or private projects. And it is useful, what are the data you are taking for analysis and design. So private project or government project, there is a, I think all of you know that there is a system that whenever we get the project, there is a principal structural engineer. Principal means who is doing the actual design and drawings and analysis. Structural consultant. And there is second, that is a peer reviewer. Peer reviewing system is also there. Means whatever design is done by the structural engineer, principal structural engineer, it will be checked by other structural engineer. Okay. Peer reviewer, he is also structural engineer. But generally this peer reviewer is maybe IIT colleges or government colleges. Okay. So generally this is the system in market, that the peer reviewer should be IIT or government colleges, engineering colleges. That means if you want to give the document, your results to checking to anybody, peer checker, then you should first give this document. That's why this document is very much important. It is used throughout the life of the project, because nobody understands without this what is the load taken for the project, what is the height of the building, or what is the soil bearing capacity. So whatever data is required for design, without this we cannot understand, and there will not be any professional way of working if you don't prepare such kind of reports. Now let's go to the design basis reports, and then once we prepare this design basis report, then we do, so DBR is the first stage, then we do the analysis in the softwares, then we do the design in the softwares, and then we prepare the drawings in the softwares. Okay. And that's why this is very important document. This is the start of the project. From structural engineer's point of view, this is the start, and the drawing is the end. Definitely there is a site work, but we only check, site checking is the work. But this is the office work end, we can say. Start of the office work, end of the office work. And then site checking is the other part. Fine. Now let's go in detail what is meant by design basis report. And this will be helpful. Actually, this DBR system is applicable in RCC buildings. Actually, in any projects, there is no any reason. RCC buildings, it may be high-rise building, low-rise building. It may be industrial structures, industrial sheds. It may be water tanks, or any project, any structure. It may be any structure, doesn't matter. Because this is the input, and it is applicable for all projects. Today we are only discussing on this part, RCC buildings. Most of the times we work on RCC buildings as a structural engineer. So there is a, we can say the people, structural engineers are working more in this field. Definitely the people are here and here also. But today my topic is this. Okay. Now let's look into this. Now, if you see this, this is a document actually in which you can write here as a civil and structural design basis report. You can put the client's name here, then your company name. Then this is, we can say, start of the document. And first part of the any design basis report is project description or project information. Okay, so if you look at this, now see, once you read this, you will understand everything actually. So as a, if you are beginner, that time also this document will help you to understand the project and everything in this. So now in this DBR project description, let's go one by one. Location is Pune. So you can understand where is the location. Functional requirement, it is a residential building. How many story are there? P plus 5 story, including future expansion. Vertical future expansion, no. See, many times in RCC buildings, the client is expecting future expansion. For example, above this 5th story, he want to construct 2 more story, but in future, not now. So you can write, because we need to take the load, additional load on the building if there is a future expansion. That's why this point is important. Horizontal future expansion means many times if this is a building plan, then the client is expecting additional building to the right side. I will just tell you what I mean to say. For example, this is your plan of the building, current plan, and currently client is expecting construction of this building only. There are columns and beams and slab, let's say. And in future, he wants to construct additional building to the right side of this. So you should mention where is there any horizontal extension. This I can say horizontally it will extend. Why I want this information? Because if this building is coming in future, then you should take the load on this column additionally for of this building. Okay, because you know that this right side building will put additional load on these columns and these beams also, right? So if you don't consider this right side, then there will be problem to the existing building in future. So that's why we want, is there any horizontal expansion of the building in future? In future. And similarly, many times people are interested in doing the construction. Let's say I have first, second, third, and fourth building. And in future, the client is expecting to extend the 2 additional floors. That means if you are designing the columns and footings, then you should also add this 5th and 6th floor. Now only. Okay, today only. I know that construction will be done for 4 story only, but I am taking additional load of 5th and 6th in columns and footings. So that's why we need to put that information here. You can see here. Okay. Now, what is the height of the building? It is as per the architectural drawing. Then height of the structure above the ground level. Yeah, above the ground level means for seismic purpose, earthquake purpose. See, there may be many terms you don't know, but at least try to understand. We are not going too much in detail of the engineering because this topic is very huge. But at least you should know what information you require. So height of the structure above the ground level means for earthquake, whenever we do the calculation of time period, generally we want this height. So there are different heights of the building actually, you know. If this is a building, and let's say your ground level is this. Okay. So there are 2 heights. One is this height. Above ground level, this height is there, H. And there is one more height. This is height till the footing level. Okay. Let's say this is HF and this is HG, for example. Now this height we require for earthquake calculations. Okay. Just remember this. How to do that, we will see that. Then planned dimension of the building 19.03 meters, 8.8. So this is your parking floor plan. So this information we get from the architectural drawing. So this is the architectural drawing. We can put the architectural drawing in the DBR. Then these are the floor plans, architectural plans. So this is actually a residential building. So you can see living room, kitchen room, and every data is there. So we can understand what is the first and third floor plan and what is the second floor and fourth floor plan, like this. So you need to put all the architecture drawing information also into the design basis report. Now, if you look at this, now you are getting the overall idea what is the project. Okay, so this is the first point. Now, second point, this is a residential building having how many floors are there? 5 floors, P plus 5, I think, right? 5 P plus 5 story. Now, the second point is what will be the construction? Will it be steel building? Will it be RCC building? Will it be load bearing? So that we need to mention here. So here you can see construction type is RCC, reinforced concrete. The basic material chosen for the structural element is RCC. And they see definitely for any building, there are partition walls in the building. So the partition walls are earthen bricks, 150 mm thick. See, each and every information is required because unless you know the material, you cannot calculate the loads. And grade of concrete used is M20 and steel grade is TMT 500. Okay, nowadays 500 grade is used, 415 is not used generally. Okay, now whenever it is RCC building, you know IS 456 is used for limit state method, and for earthquake detailing we use 13920. So this is the code. So you should mention the codes you are using for the project. And if there are water tanks in the building, overhead tanks and underground tanks, you should mention what kind of codes you are using for water tank design. So IS 3370. Okay, so all of you know this. So we are mentioning the codes also in the project DBR. So that, see, this DBR will help you. It will not create any question in your mind. And if there are questions in your mind, then you should put the answers in here itself. Now, second part, you know that for foundation design, we require geotechnical data. Okay. So generally, we get the geotechnical reports from the geotechnical consultant, and whatever required information is there, we put in the DBR. For example, let's say there is one geotech report where all bore logs are there, and in this bore log, we are getting silty sand soil and gravel soil. Okay, and the foundation is considered at depth 1.5 meter below the plinth level. See, it depends on what their geotechnical consultant knows that the hard strata is 1.5 meter below the plinth level. For example, whatever drawing I have shown here, that means, let's say this is your plinth level also. So hard strata, this is your footing level. You know, this is a hard strata. Hard strata. So from this level, it may be from ground level or plinth level, whatever. It is 1.5 meters. So hard strata level is 1.5 meter below the ground or plinth level, whatever is given in the geotech report. So here it is mentioned. Okay. And then for foundation design, we require, say, soil bearing capacity. Okay. So which is 30 tons per meter square. Generally, geotechnical engineer gives the SBC in ton per meter square. 30 ton per meter square means what? It is 300 kilonewton per meter square. Okay. Just a moment. Then no water table below the ground. See, I think all of you know this information that if there is a water table below the ground, then we should design the structure for water pressure also. Okay, if there is a water, let's say for the this project there is no water table, so we are not bothered about this now. But if there is a water table, then it should be mentioned what is the water level below the ground. Okay, it may be 2 meters, 3 meters, whatever it may be, water level. It should be mentioned in the geotech report. And this SPT value, we are not concerned much, but this angle of internal friction, phi, and C value, C phi, all of you know this, we learned in the geotechnical engineering. It is required for retaining wall design. C phi values, we get it from the geotech report. So this is the geotechnical information we need to put in the DBR. So this was something related with the foundation, means substructure. All of you know substructures and superstructure. Substructure is something below the ground. This is substructure. And this is superstructure, above the ground, superstructure. Now, superstructure, we know that we are using RCC slabs, beams, and columns in the superstructure. And the lateral load resisting system will be combination of moment resisting frame and shear walls. I think all of you know, for earthquake resistance, we generally provide shear walls and columns also, definitely. So moment resisting frame, all of you know, I think. See, the things which you don't know, don't bother, just focus on this, whatever I'm telling. For example, in structural design, see, consultant use many systems for lateral load resistance. So whatever system you are using, you just mention here. For example, there are columns and beams in the structure. Okay. So this may be the case like this. So for earthquake, people use and say these are columns and beams, and this is we can say support footings here at this level. And I can provide shear wall like this here somewhere between these columns. So this is a shear wall. So earthquake load will be taken by this shear wall and this columns and beams. Columns and beams means moment resisting frame. I hope all of you know these words. Moment resisting frame. Shortcut is MRF. So this is a combination of shear wall and MRF. So let's say generally for RCC buildings we provide this, and for steel building generally we provide bracings. So you can say if it is a steel building, you can say your lateral load resisting system is combination of moment resisting frame and bracings like this. Okay. Now this is the case. Now standards. Okay, now important point in any structural engineering is you must know the loads which you are using. So there are different types of load in any building, RCC building. It may be dead loads, live loads, earthquake loads, okay, or wind loads. Now you should mention the dead loads also, whatever dead load you are considering in the project. So in this, now if you are using the softwares like ETAB or this StatPro, then self-weight of the building. Self-weight, here you can see dead load will be calculated using ETAB with appropriate density of material. So if there are columns, beams, slabs, this self-weight will be calculated by the software. ETAB, let's say. ETAB will calculate automatically because you know that how we calculate any weight of the material. Weight is what? Weight is nothing but volume into density. So software will automatically calculate the weight of the slab and beam and columns. Okay, because we give the sizes of the columns and beams, then it will calculate volume and it will multiply with density. So there is no problem regarding the self-weight of these elements. But there are some other dead load also. So there are some other dead load means SIDEL. We generally call the loads, dead loads other than self-weight. We call it as a superimposed dead load, SIDL. So this is the general practice we use on any projects. Okay. Fine. Now, what kind of dead loads are there other than self-weight? There is you know that there are walls in the building. So wall load will be there. So if you look at our plan, whatever we discussed. Now in architectural drawing, you can see here. So there are walls, partition walls are there between the kitchen, bedroom and all, within all building. And we have already mentioned the thickness of wall. So see the importance of this thickness of wall. Earthen brick 150 mm thick we are using for the project. Why we want that? Because unless we know the thickness of wall, how can I calculate the weight of the wall? And I must know the height of the wall also, floor to floor height of the building. Okay. So this also you can mention in the AutoCAD. See, generally we get this kind of architectural drawings, and we also get the sections like this. So you can mention the section also in the DBR. You can put this in drawings in the DBR. Once you know the thickness of wall, height of the wall, you should know what is the unit weight of the brick. Generally, we get this in from the IS code, IS 875. You can see here. Okay. Yeah, दिख रहा है सभी को? So this information is given in the IS code. So everything is mentioned. This thickness, this is the unit weight of the cement mortar and brick, we can say, unit weight of brick. And thickness of plasters. So plaster we decide. So all of you know that for brick wall, there is a brick wall here, and there will be plaster also outside the wall. So you should add both the loads, the load of the wall, brick wall, and load of the plaster, internal and external plaster. Now, if you look at this, how to calculate the self weight of the wall? Thickness into density into height, which is this number. Some number is coming here. So this is the self weight of wall. Then self weight of the internal and external plaster. This is the thickness of plaster. Generally 20 mm we take from internal and external. Density of plaster into height of the plaster. Okay, which is exactly same as height of wall into 2, because both the sides we are putting plaster. So these are the loads in kilonewton per meter. So see, you may be understanding we are putting all the loads here, which is superimposed dead load, SIDL. This is nothing but dead load only. So this is the first part you should mention in the DBR. Then second part is, now there are some other dead loads also. For example, roof terrace and balcony. Generally we are having parapet walls. They are brick walls, but the height is different. So generally height is 1.2 meter for parapets. And that means you should calculate the weight of the wall for that parapet wall here. Just change this and this value will change. Again, internal and external plaster also, you need to change here and you get the parapet wall load, including plaster. So this generally it is required for terraces and balconies. Okay. See, now there is one more point here. It is written. See, actually this project, the glass railing is proposed by the architect instead of brick wall. Okay. So actually we are taking the load of parapet wall, which is a brick wall. But sometimes architects gives you the information regarding glass railing. They may suggest, I want parapet of glass railing. But generally conservative approach, structural engineer can take the load of brick load here in this case. The reason is many times architect change their decisions during the construction also. They may feel that instead of glass, let's go for the brick wall. At that time, if you have not considered the brick load, then there will be problem. Okay. So sometimes some conservative approaches you can take as a structural engineer, depending on the possibility of changes in the future. What is the next dead load? Floor finish. So generally we have the tiles in the room, kitchen, bedroom, or passages. So that means you can see here, this is a tile. So tile, what kind of, how we place the tiles? Below the tile, there is a screed or mortar, we can say. Generally, we are having a thickness of mortar 50 mm below the tile. And tile, we can take on the higher side 10 mm thickness of the tile. Okay. So how can we calculate the weight of the tiles or weight of floor finish? I will show you. Let's say this is your tile. And let's say below that there is a screed. So this is your screed. Screed is material is generally mortar, we can say. And this is, let's say, your tile. So the total floor finish load will be weight of screed and weight of tile. So for that, what you should know the density of tile and density of mortar. Here you can say unit weight of screed 24. Generally, we can take the density of screed as like a concrete, we can say, because it has a sand and cement. Then thickness of screed, generally it is 50 mm. Okay. This thickness is 50 mm. Including slope. Then unit of weight of floor tiles, it is generally, generally tiles may be granite, marble or vitrified. So if it is a granite marble, then it is as good as the unit weight is of the stone, which is 22 to 23 is there. So you can take 22 for tiles. You don't know what kind of flooring finish the client will choose in future. So it is better to take the weight of the marble or granite for conservative purpose. And thickness of floor tiles 10 mm. So how to calculate the floor finish weight? Thickness of screed into density of screed, thickness of tile into density of tile. That is the, generally it comes out to be 1.5. Okay, so this is the dead load. Now in dead load, there are other loads. Whenever there are toilets, you know that there is a sunk in the toilet. So that means for calculation of the dead load in sunk, you should also add the weight of the sunk. So there will be sunk load plus screed load and tile load. So in this case, only addition is sunk load. So what we feel in the sunk, anybody knows what we feel in the sunk? इसमें क्या feel करते हैं हम? Brick bat. Because there is a brick bat waterproofing, right?
Cinder.
Yeah. So then we can take the density of this material as of bricks. So now look at this. Unit weight of screed, 24. Thickness of screed, 50. Unit weight of tiles, 22. Thickness of tile, 10. Similar to previous case. Unit weight of waterproofing, which is brick bat. Then you can take directly 20. Thickness of sunk, this or waterproofing is 325 mm. It depends on the project. You should consult with the architects regarding this sunk. Then how to calculate the load? Sunk load kitna aega? 0.325 into density of the brickwork in this. And finish ka pata hai.
What about cinder, sir?
Yeah.
Cinder.
See, generally that whatever values we are taking, it will take care of everything actually.
Okay.
Yeah. And then floor finish, screed and tiles. So this is the total weight for toilet zone. Okay, toilet and bathroom. So everybody is getting क्या चल रहा है, समझ में आ रहा है सभी को? All of you? Any?
Yes, sir.
समझ में आ रहा है ना? Okay. And then attached terrace sunk. You know that there are balconies and attached terrace to the building. In that case, the sunk thickness is 150 mm. 150 mm for attached terrace and balconies. So sunk load will be different for this. In this toilet zone, it was 325, but in attached terrace, it is 0.15. So that is the only difference. Other calculations are same. For example, floor finish load and sunk load. Total is 4.5. Let's. Now roof terrace. What is there in the roof terrace? We have the waterproofing, which is a brick bat waterproofing. And generally, we take the depth of waterproofing for calculation as 150 mm. So that means we can say sunk is 0.15 terrace. And if you are providing any floor finish, then you can add the floor finish load also. Generally, we have waterproofing also in this terraces. So this is 3 kilonewton, 0.15 into 20. You can look at this section, the concrete slab and directly waterproofing we are doing here, right? This water parapet wall, already we have taken the load of parapet, which is 1.2 meters. So try to understand what information we are putting in the DBR, because this all information is required for the software analysis and peer review. And you know that there are staircase loads also. So staircase load pata hai kya kya rehta hai? In staircase, we have this waste slab. Waste slab means only this waste slab. Then we have the weight of the steps. What kind of loads are there? Weight of steps, then screed below the tile and tile. So we have 1, 2, 3, 4 types of loads are there. And waste slab is generally, it is a concrete. All of you know it is a concrete. Then this triangular step is also concrete. So we will use the density of concrete for this calculation. Then screed also, you know the density of screed and density of tiles. So this is given here. So all the first you need to mention the density of all the materials, screed, tiles, and unit weight of concrete. Okay. Then floor finish load. Load of the steps is, there is a formula RY2 into density. That way you can calculate the weight of the steps. Then there will be floor finish load with with tile and screed. Okay. Then staircase cap load will be there. If there is a sunk, you can put the staircase cap load also in this. Now, all of you know that whenever we do the analysis in softwares, we need to put all these loads on the beams, right? So if you don't know this, what type of load we are taking and from where we are taking, then how can you do the analysis of any structure? So that is the reason we should prepare the DBR. Otherwise, there will be a lot of questions in your mind whenever you go for the softwares. So don't jump on the softwares directly without preparation of this DBR. Please keep in mind, at least as a beginner, as a, we can say, learner, that is the way. And even in profession also, we use this method only. Because if I submit my calculations to any other structural engineer, he will ask me where is the DBR. Now there are some, see, now you know that we have taken the density of brickwork 20, but you should mention where are you taking the data. So this is the one of the important point in design basis report. You must mention all the references. You cannot assume something and you are putting in the DBR. There has to be all references from IS codes generally. You cannot say that I'm taking 21. It is my assumption. No. If you are taking 20, you should tell or write here where you are taking this value. So every value comes from the authentic document like IS codes. See, many times people do assume something, but they don't know where it is coming. If I ask you, what is the density of steel or unit weight of steel? 78.5 kilonewton per meter cube. Okay. So second question will be where it is coming from. Even though you remember it, you must put the references. So this is very important. What is the unit weight of water? 10, I know, or 9.81 generally, we round it to 10, but you should mention where it is coming. So there is a IS 875 code, which is for the loading purposes. So, or the cement plaster, soil load and everything, it is given. So references, material, what material you are using and what is the reference. Now see, now here I am mentioning this, the code reference and page number also, page number 810. And I am putting the screenshots also. So now this is too much, we can say, very easy for me. IS 875-98-7 part 1, page number 8. And I am putting the red color also. This is the density I am taking for plaster. Getting? So everything is written here. So this document is self-explanatory. Now this is the masonry brickwork. So this is the unit weight. So there are different bricks. We are taking 20 here in this. And this is for cement, plaster, 20.4. Page number 16, IS 875. So that is the loading. So now you are understanding the dead load part here in our part, and IS 875 part 1 we are using for that. And we are giving the references of IS 875 part 1. For each and every density we are considering for the load calculations. Now second part is the live load. So in any structure, we also have the live loads. If it is a residential building, There are living room, bedroom, passages, toilets, and so on, terraces. So what kind of code we use? We use IS 875 part 2. Okay. So mention which code you are using for live load. Then second part, for which room you are using what load. So living, bed, kitchen, you are using 2, balconies, storerooms 3, corridor passages 3, staircases 3, toilets 2. Now there is a question where you are getting these numbers. So these numbers you are getting from IS 875 part 2, but still where you are getting. Only reference of the code is not used. Now you will see here on the page number 7 of IS 875 part 2. See this residential building, toilets and bathroom 2, all rooms means kitchen, living room 2, corridor, passages, staircases 3, balconies 3. That is we are mentioning there. We are not assuming anything. We are just taking the reference from the code. But you should mention that like this. Okay, so that is very important part. Now this was the live loads. Now seismic loads means earthquake loads. So what kind of IS code you use for the earthquake loads? IS 1893. Either it is 2002 and now it is 2016 also. So this is for analysis and design also. This code, and this code is for detailing 13920. So you are mentioning everything, and this code is also available for, but this we don't use much. Now you should mention what is the zone of your building. If it is a Pune, I think all of you know this code. If you don't know, please refer this code for earthquake data. But for whatever information is required for building only, I am putting here. The code is big, but whatever our requirement is there, let's mention it. For example, there is a zone factor as per IS code. See here, I am mentioning the IS code. I am mentioning which table I am referring. So zone factor is given in table 2. I'll show you that code so that you'll understand it. For example, how we go into that? Or shall I show you IS 875? Live load मैं दिखाता हूँ पहले. Impose loads IS 875 part 2. See this. So this is your IS 875 part 2. So I have just taken the screenshot of this and I'm mentioning these loads. Okay. So in the similar way, go to the earthquake load 1893. Let's say, let me take part 2. So it is saying table number 2. Just go into table number 2 here. This is IS 1893. Now you can take this screenshot of this also. Now our Pune region is in zone 3 or 2. क्या लिखा है? Okay, 0.16 is the point. Zone 3. It is a zone 3. Now you should mention where you are taking these values. So for Pune, actually, do you know for in 1893 the city name of the city is given? Do you know this? See this. Annexure E. As per different cities, what is the zone factor? Zone factor and zone number. If you see in Pune, you will see this PUNE. Pune it is 3 and 0.16 is the factor. So here in DBR also we are mentioning that zone factor. Then importance factor I is equal to 1. So it is also given in the table number 6 in 1893. Table number 6, because it is a residential building, we are taking 1. Response reduction factor is 5, table number 7. I will show you. Okay, pehle importance factor table number 6. Actually, it is coming all other buildings, which is 1, table number 6. So the importance of this DBR is if you are a beginner or new in structural engineering, it will give you a shortcut, or rather shortcut, not shortcut, but all the learning is in one document only. So you are learning all the codes in the document. You know the references of each and every clause or data which you are taking in the report, so that your IS 456, IS 875, IS 1893, 3370 सब कोड का नॉलेज मिलेगा आपको. और then you will also get an idea कि कहाँ से क्या आ रहा है and where we are using in the analysis of the project. Okay. Then response reduction factor, table number 7. Why it is 5? पता है सभी को कुछ? Table number 7. See, I don't expect that you should understand if you are very much new, but at least you should know how I'm getting the information. Now, response reduction factor, which is 5 for special moment resisting frame, SMRF part 2, which is 5. This is nothing but if you are using shear walls and moment resisting frames, then we can use 5. And if you are using ductile detailing code, that's why here special RCC moment resisting frame 5. Then there are calculations of time period, fundamental time period. The formula is T is equal to 0.09 H upon root D. Refer 1893, clause number 7.6, page number 24. Let's go into the page number 24 and check it out. Yeah, see this. Okay. So this clause we are using for calculation of time period. And this root D kya hai? There is a H also, don't forget actually. Code mein kuch to galat hai. 0.09 H upon root D. So what is the height of the building? Height of the building. Now this height is whatever I told you previously. Kya tha height wo? Above the ground level. So this is my height. This one. Above the ground level. So in this calculation, H, you will put that height. And there is a base dimensions of the building at plinth level. So base dimension where you get? कहाँ से मिलेगा आपको? Go in our DBR. Now base dimension mean you should go to the plan of the building. Now you will understand why we have put that plan in the, see this. This is a plinth level, parking level means plinth. What is the base dimensions? 19.03 in this direction. And in the Y direction, it is 8.8. So this is your D value. You need to put in this formula. समझ में आया? See why we are putting all the data, because there will not be any doubt while calculations. Now again go here. See this 19.03 in X direction and in Y direction 8.81. Okay. And this is the reference of the clause. Then here see height of the building above the ground level. Right. Now there are some other calculations also, SA by G. I don't know whether you know this. Now, what kind of strata we are getting there? It's a medium soil. The gravel and sandy soil was there, isn't it? We have mentioned from the geotechnical report that there the soil is gravel and sandy. So I can consider medium soil. So there are different soils here: rocky soil, hard soil, medium soil, and soft soil. Soft soil means like black cotton soils or clay soils. Medium means in between sandy and gravel or murum, and rocky means hard rock. So this formula we will use in the calculation of SA upon G. So we will calculate the T value from this formula here. And this T value we have already calculated in DBR, 0.09 H upon root D, which is 0.371. And in Y direction, 0.45. Okay. And we will use this. We will put this T here and we will get SA by G values, which is coming out to be 2.5 here. So yeah, right? This one. So I am putting SA by G value 2.5 also. So all the calculations I am doing in the report only. And then finally, we will calculate the base shear. See, all this information is required to calculate the base shear, and the formula is AH into W. And we get this formula from the 7.5.3 clause, right? And W is the seismic weight, which we get from the softwares, okay? And there are some scale factors actually in earthquake part. So this was earthquake data we are getting, and we are even calculating the time period and base shear also, VB also, okay? AH value. So AH is this. AH is Z by 2 I upon R SA by G. And where we are getting is AH, you know, in the code. So you should mention that AH value also in the code. See this. AH into W. And where is the AH? See this AH. 6.4.2 AH. So you should mention this also in the design basis report where you are getting this AH value. So you know Z, you know I, you know SA by G, you know R. So you get AH directly from the calculations. So this is your earthquake part. So we have considered dead load, self-weight, SIDL, superimposed dead load using IS 875 part 1, then live loads, IS 875 part 2, and earthquake loads, IS 1893. I'm not taking wind load in this case, for example, as building is smaller. Now, you know, we don't design any structure only for single load like dead load or live load. We design it for the combination of the loads. So combinations means it will have a combination of dead load. It will have a combination of SIDL means superimposed dead load. It will have a live loads. It will have earthquake loads. Okay. So it's a combination. We design the structure for combinations. So there are different combinations given in the IS 456 table 18. Okay. So there is, for design, we use limit state of collapse, and for serviceability or deflection, we use this. You can understand if it is a dead load plus live load, use load factor as 1.5 and this. So limit state design, gravity design, we use 1.5 dead load plus 1.5 live load. Okay. If it is an earthquake load, wind load or earthquake load, both are same actually. So we can use 1.5 dead load plus 1.5 earthquake load. Okay. So in the similar fashion, you can develop your load combinations and you can put these combinations in the software. And software will design and analyze for each combination. So that's why you should mention the combinations also. I will show you where the combinations are there in the code. So it is given in IS 1893 also. Okay. So this is the total combination. Generally, we get around 20 to 30, I think. 30 wind load ke sath, they are coming out to be almost more than 50. Yeah? So there is a response spectrum case, wind load case. If it is there, then it is almost 55 cases. And how we are getting those cases? From 1893, you can see here. See this part, 6.3.1.2 for RCC. See, these 4 combinations, actually, they are giving you 55 combinations. Because this earthquake, there are 2 types of earthquake. One is the equivalent static method. This EQX, equivalent static method. Equivalent static method as per IS code. And there is one more earthquake load, which is a response spectrum. So we are using all this, and wind load X, wind load Y, all this. So these are the load combinations. That means you need to put all the load combinations in the software. That's why you should know what kind of combinations are there. You put all the loads in the software. That means you should know what loads you are using in the structure. So all data is required here. Then fire resistance. Generally, we should have at least 1 hour fire resistance in any building, as per IS 456. Now, environmental exposure. Please keep this in mind. This is something whether your building is near coastal region or dry region or what. So let's say if it is a moderate condition, means dry. Why we want environmental exposure? Because depending on that, there is a cover to the reinforcement. So that information also you require to be put in the DBR. So for footing, how much cover? Let's say 50 mm. As per clause and table is given here, 456. For columns, it is 40. Beams 30, all beams 30, slab also 30, chhajja 30, retaining wall and water tanks 40. So each and every cover is required. We can get it from this IS 456. Why we want cover? Because it will be used in design. Don't forget, whenever we calculate D effective, how we calculate? Total D minus cover minus diameter by 2. So this cover is required for calculation in design. So this is required in design, and that's why I'm putting values. This is also required in design and drawing also. Whenever the construction is done on site, the fitter and all this contracting team will see the cover here, and they will put the cover on the site according to this. Generally, we mention that in the code, not code, in drawings. So, working drawings, and in design we take for the defective calculation. So that's why we mention the cover in the report. Then material, what materials you are using and what are the unit weights? I think this is already considered previously. Unit weight of all materials. So for reinforcement we use steel, and unit weight PCC is also there in the structures below the footing and plain beams. RCC material, brickwork, water, cement, plaster. So this is already discussed with the references. Then you should also mention what kind of grade of concrete you are using. Grade of concrete for the project. Footing, for footing, what is grade you are using? For column, what grade you are using? Slab beams, retaining walls, and all these things. Okay. Mention what are the grades you are using in the project. If the building is high-rise buildings, you can go for higher grades also, like M40, M30, like this. Okay. So whatever you are assuming, please mention in the report so that you will consider these grades for design. It should not happen that you are changing the data frequently. Finalize this data with the client and architects, and then do the design and analysis. And reinforcement, TMT 500. Generally, these bars should have percentage elongation 14.5. ये पता है कि नहीं मुझे नहीं. It's a ductile detailing requirement actually. Okay. So generally, either it is a D 500 bars or TMT 500 bars. Okay. So this is because of this clause and IS codes. This is IS code clause. Here you will see this IS 1893. Here also you see this 500. Now please mention in this code actually the grade is 500 but elongation is 12, but we want elongation as 14.5. Please. So we should ask to the supplier what is the elongation value for your steel. If it is 14.5, then it is okay. So don't take the elongation 12 for your project. So whenever you purchase the steel, please make sure your elongation is this. So whenever you take the test report, steel test report, there you find this information. Now, second important part is in earthquake, we do the detailing, and detailing, we do it ductile detailing most of the times. So here, please mention, check it 13920 for ductile detailing, normal for 456 for normal detailing. Okay. So now whenever we do the detailing and drawings, reinforcement drawings, we mention this. It will be ensured that the detailing is simple for fabrication and placing. Please keep in mind. Many times structural engineers are giving so much steel in the structure. They are not optimizing the steel, that there is a congestion of steel, and then there will not be good concreting and honeycombing and so on. So this depends on the structural engineer. If there is a congestion of steel, then please increase the size of the beams and columns so that it will be good for placing concrete. Okay. Then cracking of concrete would be within permissible limits. This is taken care by IS 456. Whenever you design, it will be automatically taken care. What is the cracking permissible crack width in IS 456? 0.3 mm. Joint and discontinuities would be capable of withstanding the same forces. Definitely, whatever you are assuming fixed joint or hinge joint, make sure that whatever you are assuming in the analysis has to be in design and has to be in drawing. So सभी जगह सेम ही चाहिए. एनालिसिस में अगर फिक्स है तो डिजाइन में भी फिक्स चाहिए और ड्राइंग में भी फिक्स का कनेक्शन चाहिए. Reinforcement steel of same type and steel same grade shall be used for main reinforcement. So generally nowadays we use 500 grade for all the steel, stirrups and main steel both. Okay. Then whatever IS codes you are using for the project, you should mention all the codes. For example, IS 875 for dead load and live loads and wind loads. Okay, then 456 for design of RCC members, 1786 for steel. If it is a pre-stressed concrete, then 1343 is used. 13920 for ductile detailing. So all those codes you should mention in the design basis reports. Now, once you put all the information in the design basis report, then we do the analysis of the structure using softwares. So you should mention what softwares you are using for the design. So we are using, in this case, finite element method software, which is a ETAB. Okay, so ETAB we are using for this. And we can analyze trusses, beams, and plate and shell elements. I don't know whether you know this. The analysis will be 3D modeling. The deflection should be within the limit as per IS code. I'm mentioning everything here. Then suitable load combinations. We have already taken that load combination. Shall be performed and used in the design for limit state of collapse and serviceability both. So we have mentioned all the load combinations. So this is required for analysis in softwares. And beams and columns are modeled as RCC beams, and RCC walls and flat slabs are modeled as a shell element. So you know that in softwares we model beams and columns as a line element, and we model walls and slabs as a shell element. So, and the slab shall be considered rigid diaphragm for earthquake purpose. So see, so much minute detailing is considered in the design basis report. Then and then you will understand what you are doing. Otherwise, every time there will be question. Okay, and yes, actually this is also added here. Wind load. Apart from earthquake, we have a lateral load, which is wind load, part 3, IS 875. So you know wind zone, what is the location of building, zone, which is 3. Then basic wind speed, it is given in this 875, appendix A. Risk coefficient, part 3, clause number this, terrain category. So every data is given in the IS codes. Okay. K3 factor and everything. So these are the references of the IS 875. This is the wind speed calculations. And These are the K2 factors given in this table. And this is the pressure calculations, design wind pressure. So there is no doubt in this. And this is also a reference from the ETAB manual. So how they are taking the wind calculations in the ETABs. And these are the values we are getting from the ETAB manual, calculation manual. So the basis, how the ETAB is doing the calculations. So these are the things. And we finally get the design wind pressure by putting this value. Okay. Design wind velocity Vz and pressure Vp. And these are the pressure values we are putting in the table. That's it. So this is our design basis report. This total information is required before starting any project, before touching any software. Okay. If you are using StatPro or ETABS, you must have this document first in your hand, and then you can do the work. Otherwise, every stage, every point, you will have a doubts. Then what should we cover? Then what should be SIDL? What should be earthquake load? What should be the wind pressure? So you will be always in questions. So it is always better to prepare such a design basis reports and then do the analysis. So I hope all of you have got the information regarding this. अभी किसी को questions है क्या कोई? How was the session? Will it be helpful for all of you?
Yes, sir.
Yes, sir. Yes, sir.
Okay, okay.
It is a really helpful.
Yeah.
Sir,
So
can we get this copy, sir?
Sir,
we will
please,
करेंगे.
please upload these PDF file in WhatsApp group, sir.
Okay, okay.
Hello.
Hi. Any doubts, questions?
Sir, I have one question regarding that.
Okay.
Can we considering while design the ground floor structure consider as a sunk load and glass partition work in parapet walls?
Sunk load in ground means at plinth level, you are saying?
No. The structure is ground floor structure, like as a single story
Single
structure.
story, okay. On ground itself, on plinth level, huh?
Yeah.
Sunk,
Then
sunk is not required in that case.
okay, sir.
Because there is a ground itself, ground feeling is there, na? So why is sunk is? There is no slab at ground level. So no need of.
No, sir. While designing ground, only single story structure we were designing. Then can it be considered like as this? I know
Can
that.
you do this design basis report and all information you are saying?
Yeah.
Yeah, for gravity loads तो at least होना चाहिए. Earthquake load के लिए you can think of कि डालना है या नहीं डालना है. Generally ground floor के लिए नहीं करते कोई. But dead load चाहिए, live load चाहिए, SIDL चाहिए. वो तो चाहिए information सर. And sunk तो नहीं रहेगा क्योंकि वो वहाँ soil है already. और बाकी लोड तो है, wall load है, बाकी लोड्स तो है, plaster है. Only there will not be. But for terrace, if on terrace there is a future extension, first floor अगर करना है बाद में, if you want to do the first floor in future, then you should provide the sunk at terrace. Okay.
Okay.
Yeah, terrace में करना पड़ेगा.
Thank you.
Yeah. Any other questions?
हॅलो सर, याच्यामध्ये सर वॉटर टँक लोड कन्सिडर केला नाही का? म्हणजे
हा करू शकतो ना आपण. आता याच्यामध्ये दिलेलं नाहीये, बट इफ देर इज अ वॉटर टँक then you should mention the water tank capacity and the load also and the location of water tank.
कोणत्या पोझिशनला आहे त्यानुसार डिझाइन बदललं.
Yes. So actually, yeah, in this it is not mentioned, but I will say you should mention whether what is the water tank location. For example, if this is your plan, then please mention. You can do like this, for example, and hatch this portion. and say water tank, overhead water tank, overhead water tank. Okay. So this you can mention. So this is your water tank location. Yes, it can be mentioned, right? The more
Sir, loading,
information
sir,
you
sir.
put, huh?
Loading, sir, loading.
You should mention the capacity. Capacity, let's say. So you can separately calculate the loading for the water tanks. For example, how I will do in this case, I will just tell you. क्या होना चाहिए? See, we can put lot of data in the structure. अभी ये है समझो. So how will I put that? So I will put the location first. ये समझो मेरा staircase है. This will be my plan of water tank. I don't know the dimension, but let's say 4 meter by 2 meters, for example. And you can even draw the sketch of the water tank like this. Then you can draw a cross section. Correct. And maybe top slab is there. And there are 4 columns for the water tank. And mention the height of the water tank, let's say 2 meters. This is a water level. Then thickness of wall, let's say 200 mm. And the water tank capacity, let's say 15,000 liters. Okay, liters. Then you know the water here inside the tank, you know the thickness of wall. Then you can calculate the weight of tank. So there are 2 things. Either you can calculate the weight of tank total and apply the load on softwares, or you can model the water tanks also. So this way you can mention in the DBR water tank, overhead tank details. Correct? Any questions? It may happen that we require any other information also. You can mention everything here. If there is a communication with the architect and they are saying something, add that point also. Okay. Any other questions? कोई questions है क्या?
Sir, should we put the beam, sir, if there's no wall load, sir, in the plinth beam?
Plinth beam, the model will calculate automatically, self-it.
Seismic analysis करना जरूरी होता है क्या सर?
See, if the building height, generally I recommend if it is more than 4 or 5 story, then you should do it. See, technically it has to be done, but many times for smaller buildings like 2 story, 3 story, people generally don't do. But as per code, it has to be done actually.
Okay.
As per code, if you ask me, it has to be done. But for 2 story, 1 story, 3 story, log nahi karte. They only do the ductile detailing and just don't do that calculation generally. So it's up to you how you are tackling with the client. If it is a government building, then you must do it, even though it is a single story. And if it is a private building, then there is a freedom to you whether to do it or not. But technically speaking, it has to be done.
हॅलो सर.
Uh-huh.
जनरली काही बिल्डिंग मध्ये ऍज पर आर्किटेक्चर प्लॅनिंग नुसार काही कॉलमची पोझिशन बदलते फ्लोर टू फ्लोर वाईज, म्हणजे फ्लोर टू कॉलम काढावे लागतात. त्या केसमध्ये डिझाईन बेस कोडला काय त्याच्यामध्ये आयएस कोड कुठला येतो का वापर?
Now, IS code nahi hai. You are designing, as per the analysis results from the software you are designing. It depends. Once you get the bending moments for the transfer beams and floating columns, you design it accordingly. Only you need to put the architectural and structural drawing in the design basis report. That's it. There is nothing different actually in the floating columns. Okay, nothing different. Okay, yeah.
आणि शेअर वॉल केव्हा प्रोव्हाइड करतो सर आपण नेमकं?
For earthquake. For earthquake resistance, we provide shear walls.
Okay.
If you are designing the building for earthquake, then the shear wall must be there. And most of the times, by default in RCC building, there is at least one shear wall. कहाँ रहती है पता है? Where is the shear wall we have? It is compulsory.
लिफ्ट में.
Lift. So lift will have a shear wall, RCC wall only. There is a always compulsory shear wall in any residential building. Minimum lift as per the corporation and bylaws. Okay. ये तो होता ही है. Now, if you are building, let's say there is earthquake load in this direction and your building is not taking earthquake load or the deflection is more due to earthquake, then you can add some additional shear walls like this. ऐसे बीच में कहाँ तो डाल सकते हैं. It is up to, by looking at the architectural plan, you can suggest the retaining walls. Say यहाँ या वहाँ में भी यहाँ कहाँ तो ऐसे. Okay. So number of shear walls and length of shear wall depends on the earthquake force. Okay. And if there is a problem in this direction, then you can provide some shear walls in this direction also. ऐसे. So you get that idea after the earthquake analysis. Yes.
Sir, what is the difference between column and shear wall? Main difference.
Okay. See, column, let's say, if this is a column, okay, and if there is a horizontal load on the column, let's say, then all of you know that it will bend, right? So there will be bending of the column, or rather I would say थोड़ा bending ज़्यादा निकालता हूँ as the depth is. So this is your bending, okay. Generally columns are having size छोटे रहते हैं 600, 700. Let's say 700 mm is then this is your horizontal load, maybe earthquake, wind or whatever. So there is a bending. So due to this bending, there will be bending moment in the building, in the column, sorry. So the bending moment diagram will be something like this as it is cantilever. ये bending moment diagram है. Then there will be shear force also, which is a rectangular, okay. Now if you look at this, from here to here, it is having more displacement. Delta is, let's say, 100 mm. And there is a quite more bending in this. Can you see this curvature shows that there is a bending, much bending. Now, if you look at the shear wall, abhi shear wall lete hai, example. Abhi right side ko main shear wall nikalta. Now, if there is a shear wall,
Please share your screen, sir.
share nahi hua kya? Ek minute.
Line.
Anybody is sharing? किसी ने किया है क्या? Is it clear now?
Yeah.
Now you see, this is a 700 mm width column and there is horizontal load on this column and it will bend due to the loading. So there is a bending moment in the column, M bending moment here and shear force. This is a shear force diagram. Now, if there is a shear wall, then shear wall is having more dimension in plan. Okay, see, this is the shear wall. Height is same, let's say. Now, what will happen due to this? See, this is, I can say, bending deformation. The curvature shows it is a more bending deformation. Now, if you, let's say you are putting the same H force here in the horizontal direction, how should it deflect? ये कैसे deflect होगा? So there will not be curvature because this dimension is very large. Let's say ये 2 meter है मेरा समझो, 2000 mm. So that means it will not bend like this. You can imagine also. So it will have a, we can say, almost linear like this, almost. The delta will also be less and there will not be bending curvature, but it will have a translational, or we can say line-wise deflection. Okay. See this. That means here there was a more bending deformation and therefore more bending moment and less shear force here because bending is more. In this case, there is more shear deformation, which is clear from this. A curvature, there is no curvature, it is translation like this. Diagonal, we can say. Yeah. So more shear deformation. Definitely there is a bending, but bending moment is very less. So, and less bending. Why it is happening? Because this dimension is very large. So definitely in columns, there are bending moments. In columns, there are shear forces. In shear wall also, there are bending moments, shear forces. But in shear wall, this is dominant and more. And in column, this is more. We need to design for both the forces. In both the cases, the difference is shear deformation and bending deformation. Are you getting? Is it clear to you? Prasanna?
Yes, sir.
Okay.
Thank you.
Okay, so shall we conclude today's session?
Yes, sir.
Okay, so thank you all for attending the
Thank you,
session. Please use
Thank
this,
you. Thank you very much.
develop this for your projects also. This you'll learn a lot of things if you prepare your design basis report. Okay, thank you all.
Sir, please
And
share
good day to all
the
of you.
report copy of
Please
this.
share this PDF file in WhatsApp group.
Yeah. We will share. Yeah. Thank you.
Thank you.
Thank you, sir. Thank you.
Thank you.
Thank you.
Thank you, sir.